Hey, Marcus House with you here. Today we are talking about the Saturn V rocket, and while I am talking about it, I'm going to show you some footage of me putting one together. I've only just received the Lego Saturn V kit in the mail. It took a long time to arrive. There was quite a back order for this. You can see there the building instructions. Quite a thick little booklet there, and yes, this is just me unpacking the bag. You can see there is just loads and loads of pieces. There's 12 bags here in total, 12 steps to this process, but I'm going to obviously not show this in real time, otherwise you'll be bored out of your mind while I'm talking. So opening the Saturn V building instructions here. And as you can see, it's a really nice booklet, much more in depth than any normal Lego instruction set. You'll see we've got all sorts of information here about the Apollo program, which I'll go through, information about the Saturn V, the different stages, the breakdown of the vessel, and of course the journey to the moon information there as well, and just some information on how this whole kit came together there by the fan designers. So I will read through a lot of this material for you here shortly. Starting off there, opening bag 1, and that's obviously going to form part of the first stage, and actually the first 6 bags are all part of the first stage from memory. Now, of course, for those of us that are very passionate about the space industry, the Apollo program was just amazing to me, more because they were able to do this with the technology that was available back in the 1960s. So on May 25th, 1961, of course, President John F. Kennedy challenged his country to safely send and return an American to the moon before the end of the decade. Now, NASA met that challenge with the Apollo program, and it would be the first time that human beings left Earth orbit and visited another world. The Apollo program played a crucial role, of course, in space exploration and made it possible to explore more distant worlds further in the future. The Apollo program consisted of 11 space flights. The first 2 missions, Apollo 7 and Apollo 9, were Earth-orbiting missions used to test the command and lunar modules. Then the next 2, the Apollo 8 and 10, tested various components while orbiting the moon. Also taking photographs, of course, of the lunar surface. Apollo 13 obviously did not land on the moon due to various issues, malfunctions and whatnot. A total of 6 other missions did and returned with a huge amount of scientific data and almost 880 pounds of lunar samples. Now, a lot of people think that Apollo 11 was the first mission to the moon. In fact, Apollo 8 was the first mission to the moon. It circled around the moon on Christmas Eve in 1968. Just over 6 months later, on July 20th, 1969, the world witnessed one of the most astounding technological achievements of the 20th century when a NASA astronaut on Apollo 11 became the very first human to set foot on the moon. So the very first to actually land on the surface. So the very first stage of the Saturn V, which was called the SIC, was built by Boeing, and it was basically built in the same area that later on the Space Shuttle external tanks would be built by Lockheed Martin. Most of its mass, of course, was with its propellant, so it was fueled with RP-1 with liquid oxygen as the oxidizer. It was 138 feet tall, which is 42 meters, and yes, it was around 10 meters in diameter. Of course, the total height of the rocket was much more than the 42 meters. That was just the height there for this first stage. It had a dry weight of around 289,000 pounds or 131 metric tons, and then fully fueled at launch, this stage had around 2,300 metric tons of mass in it. So the largest and heaviest single component of this first stage was the thrust structure that had a mass of around 21 metric tons, and of course this was supporting the entire thrust of the massive 5 engines, which we'll talk about here shortly, underneath the rocket. And there was 4 main anchors which held the rocket down, and yes, these were among the largest forgings apparently produced in the US at the time. 4.3 meters long and 618 kilograms in weight, so Wikipedia is telling me. So above that thrust structure was the fuel tank containing 770,000 liters of RP-1 fuel. The tank itself had a mass of 11 metric tons and could release around 7,300 liters per second. Now, nitrogen was bubbled through the tank before launch to keep the fuel mixed. During the flight, the fuel was pressurized using helium, and this was stored in tanks above the liquid oxygen there. So you can see why this vessel is kind of broken in the middle like that, because the next area at the top there where the USA flags are basically the tank that holds the liquid oxygen, which was around 1.3 million litres was the requirement there. So getting close to, almost double the requirement there of the RP1 fuel. So there was a huge amount of mass there in that top segment of the vessel, which is why it looks bigger there in the Lego model. So speaking of the model, you can see there that I'm just slowly building up all the edges of those of the tanks there, basically creating that entire first stage. It's very detailed. You can see a lot of the smaller parts there, and I'm just rapidly putting it together. Obviously the footage here is sped up very dramatically. But to be honest, it was really quite simple to put together. It wasn't a difficult model to put together, and this is mainly because everything was essentially set up in a bit of a Symmetry 4 situation. If you're used to playing Kerbal Space Program, you'll drop a lot of your parts on in a Symmetry 2 or Symmetry 4 sort of situation a lot of the time. So essentially you would have to build up one component, and then you would build the same component 3 more times. So with the exception of some of these more intricate piping parts that were only running up 2 sides of the model, a lot of this stuff could just basically be built 4 times over. The other thing I was really happy about was the actual price for the model. You can go and get a branded sort of, if you were buying, say, a Minecraft Lego set or any other sort of branded Star Wars set, to buy something with this number of individual blocks in it would cost you much more. This was very cost effective, and if you check out some of the prices there on the Lego website, you'll see that it's considerably cheap for what you get in this pack. Opening bag 5 there now, you can see we're getting quite close now to finishing off this first stage. Obviously, the engines are going to be the last part to go on, which I want to talk about when we get to that point in the footage. But yeah, I've always been a big fan of Lego. I have 2 kids myself, and they are going through a good Lego phase. And I used to love this stuff when I was a kid. And I must admit, I haven't put a lot of Lego together myself for quite a long time. And I genuinely enjoyed putting this together. I haven't had fun like this with Lego for a very long time. So I guess one of the main parts that really made me excited when I first opened the pack was the instruction manual. The Saturn V booklet really sets this great tone for the entire build, and it generates a sort of a sense of excitement in what you would get if you were building a fairly complex model. You just kind of want to read through this whole thing. It's just really well put together. The diagrams are beautiful. The information in it is just nice, slim and concise, and I'm reading some of that through some of this episode as well. Just emptying out here the bag containing all the parts for the 5 Rocketdyne F1 engines. So these were arranged around the bottom of the vessel. We had 4 arranged in a square, and then a 5th in the center. So the center engine was held in a fixed position, so that didn't gimbal at all, and the other 4 engines on the outside there could basically gimbal around. They were hydraulically turned, essentially so that they could steer the rocket. So in flight, the center engine was turned off for around 26 or so seconds earlier than the other 4 engines, and that was just to limit the acceleration because the G-forces were starting to get pretty high by the time most of the fuel had drained out of this massive first stage. All 5 of the F1 engines firing together produced a massive force of 34,000 kilonewtons. Now that it's a figure that is hard to comprehend. I mean, even the turbo pumps that were needed to pump that volume of fuel through those engines so rapidly was just colossal. Apparently, what I'm reading on one site is that the turbo pumps needed the power of 30 diesel locomotives to force essentially 15 tons of kerosene and liquid oxygen fuel per second into the 5 F1 engines. Now, that is a colossal effort by itself, and then of course the first stage had to burn all of that fuel efficiently, and with the massive amount of fuel in it, the entire first stage burned for only 2.5 minutes. Of course, after all of the fuel of the first SIC stage of the Saturn V rocket was all burned up, the entire thing became a massive paperweight, and it needed to be separated to make way for the second stage, which you can now see me starting to build here. Now, the separation of those two stages was quite a complex process. It all happened very rapidly, but essentially there was these little retro rockets, and they were located inside each of the 4 conical engine fairings, and basically at separation the 8 retro rockets fired, blowing off removable sections of the fairings forwards of the fins and backing the SIC stage away from the flight vehicle as the engines on the stage 2 were ignited. Now, the architecture of the second stage was actually a little different. This wasn't fueled in the same way. This was fueled using liquid hydrogen and liquid oxygen. It had 5 Rocketdyne J2 engines rather than any of the F1 engines. The F1s were just way too big. So the J2 engines were, I guess, in a similar arrangement to the SIC first stage. They used 5 of these engines, 4 again around the outside and 1 in the center. So the stage 2 had the exact same diameter as stage 1, so it was 10 meters in diameter, but it was just a little over half the height of stage 1, only 24 meters tall. Well, I shouldn't say only, that's still damn tall, but compared to stage 1, which was 42 meters, it was just over half of the height. One of the interesting challenges with the second stage was that they were needing to store that liquid hydrogen. Now, the liquid hydrogen obviously had to be stored extremely cold, just around 20 degrees above absolute zero, or 20 Kelvin. Unlike the first stage, which had 2 very separated tanks, the stage 2 actually had a common bulkhead between the 2 tanks, so that actually helped to cut down a lot of weight, around 3.6 tons. As with the rest of the vessel, the vast majority of weight in this thing was fuel. Over 92% was the liquid oxygen and liquid hydrogen in this. The liquid oxygen, though, was around 357,000 kilograms, while the liquid hydrogen only around 69,000 kilograms. So again, most of the weight was in liquid oxidizer. So as I'm rapidly building this second stage here, you can see the architecture of it is quite similar to what you saw there on the first stage. Basically, you build up this central core, all sorts of support structures and that sort of thing, and then you essentially add all of the outer layers on it piece by piece. It's actually a very, very solid thing. Like I suspect I could probably drop the thing on the ground and probably not lose too many parts off it that I'd have to put back on. So it is very stable, and yeah, it's built just really robustly. I was really impressed. It does take a long time to put all these little internal structures together, and well, frankly, you don't really see any of them because they're all going to be covered over by the outer shell of the rocket. But all the same, when it is put together, you do feel that there is considerable weight and structure to it. So, you know, it doesn't feel flimsy in any way like what you would get if the entire model was just an outer shell and everything inside was just empty space. You can see as well, just from the box that's been in the shot the entire time, that there's been considerable amount of effort put into a lot of the illustrations and the design of not only the box itself and the back that you can see there, but also, you know, again, certain areas of that booklet. So you can see there with that second stage that most of the time spent here is building up all those internal structures, and actually, as you see me now rapidly building that outer shell, the rest of the model comes together really quite quickly. Just putting this outer shell on takes almost no time at all. It's just a matter of building up these parts, popping a lot of those quite large shell pieces on, and you're basically done. It's just a matter of then plugging them all in, and yes, we are then on the final bag of this stage 2. So this bag here now, bag 10, has got the engines and things in it as well, so we can talk a little bit about the J2 engine capabilities. The J2 engines, of course, were much more efficient. They had a much higher ISP compared to the F1 engines on the first stage, which had an ISP of around 263. The J2 engines and the second stage had an ISP of around 420. So where the first stage basically gets the entire vessel up out of the atmosphere and clipping along pretty quickly, the second stage does get the vessel moving right up there. It's got a delta V of around 5,500 meters per second, whereas the first stage had a delta V of around 3,500. So yes, you can see the second stage got the vessel right up there, almost to orbital velocity. It got it to around 6,500 meters per second, whereas orbital velocity is around 7,700 meters per second from memory. So yes, the second stage did a lot of the grunt work, leaving the third stage to obviously just finalize the circularization of orbit around Earth. So you can see here as a final step to the second stage, just adding those 5 J2 engines there. And yes, basically this then pops up there on top of the first stage, and we can continue on to building the last few stages of the Saturn V rocket. So bag 11 and 12, the last few bags there. And yes, just basically now making the third stage. Now the third stage of the Saturn V rocket was the SIVB stage. This essentially was powered by just one of the J2 engines, the same engine that was used in the second stage, and also the same fuel mixture as was used in the second stage. So the third stage used again a common bulkhead to separate the two tanks. It was around 17 meters tall, with a diameter this time of only around 6.6 meters, so it was quite a bit smaller in diameter than the previous two stages. This third stage had a dry mass of around 10,000 kilograms, and fully fueled it weighed around 119,000 kilograms. So essentially this vessel, or this part of the vessel I should say, is less than half the mass of the stage 2. So you can see there things dropping very rapidly in weight as we get up in the stages. This of course also means that the delta V is increasing quite considerably as we get up here in the stages. So stage 2, which had a delta V of around 5,500 meters per second, the stage 3 here had a delta V of around 8,700 meters per second. This third stage also had quite a bit of an advantage because it didn't have to worry too much about the amount of gravity losses that were incurred by not burning the fuel quite quickly. So the amount of thrust there was only around 0.6 to 0.7 G. Of course, there was basically no atmospheric drag at this point in the launch ascent profile either, so yes, the fuel was able to be spent extremely efficiently, and this allowed it to not only circularize the orbit around Earth, but also it was able to cut off its engine after circularization and then complete a second burn to intercept with the Moon and prepare for the next stage in the mission. So emptying out the final bag here, this is the rest of the vessel, all of the command modules, the lunar module, and you can just see, look at the scale of this thing. These are little tiny Lego men. These are obviously not the regular Lego men. This is to scale, so that is the size of a human being compared to the Saturn V rocket. Just colossal when you look at it like that. So around 30 minutes or so after the translunar injection burn, it was then time to do some complicated little maneuvers. This involved separating the Apollo command service module from the rocket stage, the stage 3, turning around basically doing a 180 and docking with the lunar module, which was still attached to the third stage. So you can see there I've just built the little command service module. It does still have the escape tower on there, and that's essentially because the model is built there so that the entire thing is as it would appear on the launch pad. So obviously that escape tower comes off as the second stage is doing its burn. Now that command and service module was obviously two pieces. The command module was the cabin that housed the crew for the 3, along with the equipment needed, and the service module provided essentially the propulsion, the fuel, electrical power, all that sort of thing. The command module, of course, was the only part that came back to Earth. The service module would get cast off just prior, and that would essentially burn up in the atmosphere, and the command module would be the only little part to come back down. Now you can see here I'm just putting together the little lunar lander. This is a cool little groovy thing. Check this thing out. If I can get the camera to focus, there we go. Yeah, just a nice little neat unit. That was the ascent stage, and then obviously we can put the descent stage on there for the lunar lander. And there you go, there's the little guys, little flag, that little scene set there, and then we just have the final little command module there that comes back down, lands in the ocean. And look, that is basically it. We can set up some little stand pieces here, which comes with the kit, which is quite handy, which means you can just lay the entire vessel down horizontally, and that's just a nice alternative if you want to display the Saturn V there in a horizontal position. Of course, you could store it vertically as well. And there we go. The model is complete there, just zooming in on it just so you get a little bit more of a detailed shot. And look, I just really loved making this. It was just a lot of fun. There's our little lunar stage there, a little lunar lander stage. the command stage there. It does come with one extra little astronaut, which is cool, so we have 4 there. So there we go. I hope you enjoyed that video. I know it was a little bit different to my usual Kerbal Space Program stuff, but I just had to share this with you. It's just so damn cool. You know, hopefully this inspires some people to order this thing and build it themselves, because it's a great little prop to have in your home. If you have any questions for me, please do whack them down in the comments below. If this video has earned your subscription, welcome to the channel. And for all my existing subscribers, thanks for being awesome. In the tile in the bottom left, I have an Apollo mission that I did not too long ago. In the top right, a latest video. In the bottom right, a video that YouTube has chosen just for you by some bizarre little robot. Thanks for watching, and we'll see you all in the next video.